So welcome back. It's been only several hours, I suppose, since the last video, but that's because of the contest schedule. And like right now we have LC Biweekly, and previous time it was 5 a.m. Today it's 5 p.m. It's a beautiful time for all Europe, I suppose, to take part in LeetCode contests. But you also have to keep in mind that because of that time difference, the sets of participants, they are very different, so rating changes that you can expect will also be different because you kind of compete against two different groups of people. But I think we don't care that much about ratings. We are here to solve some problems. That's it. That's basically why I do competitive programming, because I usually like solving problems. I don't always like problems that I have to solve, but mostly. I hope it will be an easy contest because I spent a little bit too much time thinking about LeetCode beginner contests, so I think not in the prime shape for yet another contest, but whatever it was. It won't affect the performance too much. I mean, if everything's better than 5 a.m. Let's go. We'll start in a second now. We will open all problems and solve all problems. That's a good plan. Okay. 1, 2, 3, 4. Close this. A sentence is a list of words that are separated by a single space with no leading or trailing space. Each word consists of lowercase and uppercase English letters. Sentences can be shuffled by appending the one indexed word position to each word sentence, rearranging the list of the sentence. The sentence, okay. Even a shuffled sentence, okay. So basically what we do is words get a split sentence. I'm gonna create a list of like nothing times len words, because that's how many words we'll have. And I'm gonna say that please join sentence for word in words. What I'm gonna do, digits from 1, 0, no more than 9 words. Okay, it means that index gets word -1 last thing, and actual word should get word up to that location, and sentence at index should get word. Let's run it. We did something bad because we should have subtracted 1 from index. Come on, it's been like half a minute already. No, we're still getting something wrong. Len words. Wait a second, like it should be fine now. We take the last character, it is a digit, we convert it to integer, we subtract 1 to get the correct. Oh, probably I should just do it like this, right? This is a sentence, me, myself, and I, me, myself, and I. Okay, submit. Accepted. Next problem. Incremental memorylic. We are given two integers, memory and memory2, representing the available memory in bits on two memory sticks. There is currently a faulty program running that consumes an increasing amount of memory every second. At the I second, starting from first, I bits of memory are allocated to the stick with more available memory. Or from the first memory stick, if both have the same available memory. If neither stick has at least I bits of the value, the program crashes. Turn an array containing crash time memory 1, memory 2, where crash time is the time in seconds when the program crashed, and memory 1, memory 2 are the available bits in memory, the first and second sticks respectively. Well, because of the way it's structured, like during first I seconds you will around big O of I squared memory will leak, which leads to the following observation. Like we will finish in at most half of this time, which is, no, not half, but square root of this time, which is absolutely beautiful, because now we can do, what we can do is we can just use the heap, or no, we can't, that's irrelevant. Okay, with more available memory, okay. We don't want to use heap, we will just do for I in range 1, and then I suppose like 1 million should be enough, because 10/12 over 2, 10 to the 11th times 5. Yeah, it should be fine. So if memory 1 greater than memory or equal to memory 2 and memory 1 is at least I, memory 1 we decrement by I, else if memory 2 is at least I, we decrement memory 2 by I, else we return I, memory 1, memory 2, I suppose, just like this. We should return 310604. Looks very reasonable. I don't know. Can it be something like, let's say 00? Will our program work? Oh, we don't know what's the expected crash time is when program crashed, so if it could not allocate I bits. Here we check if memory 1 is at least memory 2, then we will allocate from memory 1. If we can allocate, I should do it like this. If memory, like just to be extra safe, okay? If we, like it means, this means we should allocate from the first one. This means we can allocate from the first one, then we allocate, we can't allocate, then we return. Else we will allocate from the second one. So if we can allocate, then we allocate, if we can't, then we return. Let's just check that nothing changed. No, looks legit. Okay, got accepted here. Problem 3. We are given an m times n matrix of characters box representing a side view of a box. Each cell of a box is one of the following: a stone, a stationary obstacle, and empty. The box is rotated 90 degrees, causing some of the stones to fall due to gravity. But they don't fall through a station. Oh, I've seen a very similar problem on binarysearch.com. Bro, how do we solve it? How do we solve it? I assume that we want to just so first of all, obstacles fall in every row by itself, so why don't we create a function def solve of row? I don't know, for now it will return row, but then we will update it, and then we want to, what? We want to say that box, like, we can update it for every rocks in, for every row in box, we can update it, and we will return, I should transpose it, and I believe that the way to do is like this part. So for now it should just transpose it, right? Wait, what? Board? Box. Okay, that was box. Okay. Oh, do I have to? always forgets where do I have to zip. So here it looks like we transposed it, right? We had one row and then now we have 3 rows. Here we had 2 times 4, now we have 4 times 2. Yeah, looks reasonable. Now we just have to fix whatever row is, because in every row they fall. How do they fall? How do they fall? That's a good question. Every row we can have empty stationary obstacles and a stone. Stone falls, I suppose, right? Okay. New row, that's terrible name. Like entry, I don't know, in row but reversed because they fall down. What should we do here? We should keep track of how many stones we have and what was the last position. Okay. Stationary equals ln row. That's a stationary obstacle. Stones count starts at 0. If entry is equal to empty space, then we do nothing. So we should actually care about this kind of stuff, and that's a stone. In this case, we just increase the number of stones that we see. Else, if entry is equal to a stationary obstacle, then we should push a lot of stones to new. I believe it's done with extend, and then we say like, well, it's actually stones times stones count. I assume that you can multiply list by 0 and you will get empty list. Now we should extend it by this times what actually? Last stationary should get updated. We also will need index, so that's actually reversed. Enumerate. Why do we enumerate before we reverse? We cannot reverse. We cannot reverse and enumerate, right? So last stationary actually should get 0. Here last stationary will get updated. Oh, then it's -1, right? And what it should get multiplied by is index minus last stationary. That's how many whatever stones, how many cells we had, and then we also subtract stone count. Stone count should reset to 0, and I believe that we should return reversed mu actually. Yeah, it's like we abandon nothing, right? Am I right? Let's think. So we had 2 stones here, they've fallen down, we appended correctly, everything looks like this. Here the stones should form something like this, so... Oh, they don't actually. Why don't they? Like this should be on the left, am I right? Yeah, it should be on the left. It's on the right. Oh, because we rotate and not transpose, because I'm stupid. Okay. Well, okay then. What is rotation actually? Yeah, no, that's not a big problem. Now, in this order, we will loop first over j, then over I, so len box 0 goes, no, then box, and here then box 0, I suppose. But some of them should change. Like if I just do ij, then it's transposal. If we transpose, then we also want to reflect this way, which means we should say like this, I assume. On the left, good. Then we should have here it looks like this, here it looks like this, and we have two guys and a stone, and we have one guy and dots, one guy and dots, one guy and dots. Looks reasonable. I don't know, let's submit. Oh, taking a long time, it's bad, that is bad. Okay. So we did something wrong. What is this? Expected. Wait, did we? Oh, because I'm stupid, I completely ignored that we have to append like these guys actually. How did it even pass anything? If I did not append this here, how did it pass anything? Excuse me? And now it's last index out of French. Maybe this is a current index, this is the last stationary index. Let's think, if index is 3 and last stationary is -1, it means that we actually seen 3 stones and not this, so I assume this should fix it. The last, no, this is not the last one. Actually, this was our sample test case and I somehow missed it. I don't know. Oh, I must have not checked this, guys. Okay, yeah, like I inserted one too many dots and one too little stars. So now we should submit. Oh, that's also bad. No, okay, we got accepted. Sorry guys, that was just me not paying attention. Problem 4, sum of floored pairs. We given array nums, we want to return the sum of floor nums I over nums j for all pairs of indices ij in the array. They are not ordered, so what we're going to do here is like whenever you divide bigger by smaller, you get 0. No, whenever you divide smaller by bigger, you get 0. So reasonable thing to do seems to be nums.sort. Answer should get 0, and the end will return answer. Now we, oh, that's actually bad. No, it's not bad. We just will, actually. You see, my idea is it's, oh, we also divide the number by itself, well, whatever. Original idea was to loop out in the reversed order, so that when we consider an integer, we have to count everything that comes after it, divided by it, rounded down. Then rounding down may result into multiple issues, and because you round down separately. For example, here rounded down, we want 5 rounded down, divided by 2 rounded down, and 9 divided by 2 rounded down. You can't just keep track of sum and then divide, which is uncomfortable. Which is not very nice. How do we do it then? The knobs are small, I must say. We have to lever this somehow, or at least it will help us in the bounding stage. There are not that many possible values that one can have when you divide and round up. I think there are like, well, at most you will get that result of the division. That's not what you really want. And I also thought like when looping the other way definitely doesn't make sense, because then you will have to do what? When considering number 9, you will think what remainders it gives modulo 2, modulo 5. Yeah, dividing by different numbers seems complicated. Our most realistic chance of succeeding in this problem is that we have a number and we want to divide everything after it by it and round down. The problem is that we can't just use... I don't see a simple, like very simple way to make to put all of these divisions into one division. Actually, this condition, this inequality may be just for cosmetic purposes. If you have numbers too large, then your total sum may overflow even in 64T, but that usually is not a problem, but whatever. So we really have to think of a fast way to divide a lot of numbers by one number, round all the quotients down, and take the sum. How do you do it? So we have... Oh, it's not very interesting. You have to do it quickly, but how? So we want, for example, like 9/2 plus 5/2, both rounded down. That's not clear. Like ideally you would like something like this to hold, but it clearly doesn't hold. Yeah. That's wrong, because otherwise it would not have been a hard problem. So we really want to do that, am I right? Maybe as we go we can adjust some things. But no, like it's problematic if we have something like why would you? Okay. Like this, then first we would like to compute this, and you may think like, okay, we round down here, but then here you want to compute this. So that is, you cannot just assume that you rounded down 5 here, because here, like if you do it here, then here it leads to your own cancel. So it's not clear what we should do. We keep track of numbers that we had. That we've seen previously. then we would like to see something. Maybe we should actually think about the quotients that we get and group by quotients, but I don't really see a nice way to do it. So what was the idea of whoever came up with that problem? Well, it's never bad. I hope it's not a well-known problem. Come on, don't say that FAIAJ is. No, okay, that's not interesting. Seriously, like this? Yeah, I know, but that, whatever. Yeah, so you really need it, so. So sad, okay. Well, okay then, yeah, that's the second idea that I had, that we want to group by quotients. So what we'll do is exactly what they're saying. Where is it? We calculate max CMT. Okay. We take counter, then we say like, okay. Actually, that is. Yeah, I want to use both at the same time, but I can't. Okay, what's up? Max nums plus 1. Oh, I should just use like. Not like this. Max plus, I don't know, plus 10, plus 100. I'm not a bad person. Also here. Actually, then you don't need this, but what you need is like you say, okay, b equals list reduce. Do you want 0 here or not? Oh, we want to in reverse. Right, because we want to know how many numbers are greater than something. Okay. I will just use a for loop for this purpose. So I take from max minus 1, and I decrease as long as I should. That was actually useful. So I compute suffix sums of these guys. Assume that I will start like here, because yeah, this approach doesn't count directly people pairs II. Then we indeed loop over all divisors and multiples. That's so sad. Okay. So all divisors, actually we should start from 1, go all the way up to max. Exclusive doesn't matter because we added an extra 100. For j in range what? I assume I max with step I. Yeah, you can do it, you can ignore that continuous statement, so what we really should do is, well, that should be here. And this is like we computed B, we computed C. Here we compute answer. Let's say, let's think how many numbers. I assume that I want something like J over I is like, what is the multiple? Oh, I should just do it like this because this integer division will be super slow. So here we have J equals I times K, then which numbers give that sync? Which numbers give that sync? Which numbers give the floor value of quotient equal to K? I assume that it's B of J plus I minus Bj, something like that. Bj minus, all right, because it's computed in reverse, so therefore we should do it like this. And we should not get out of the boundaries, so here we'll take minimum of max minus 1 and this, and I assume we also want to, like, this only counts if we only had one entry of I, but we also want to count like this to address the fact that we can have multiple occurrences of the same number I in our array. List index out of range, probably max minus 2. It will name n is not defined. Why is that? Because it's len nums. Because every number divided by itself should get. Wait, actually, we may not need it. 1049. Do we have an example here? Yes, we have an example here. Never bad, never hurts. They say the answer is 27. Our code prints 27 as well, but it took a lot of time to execute, but I don't see how we can improve because it is just like the property of that thing. I really hope it doesn't get judged by the sum of the test cases, because otherwise this approach sucks. But I don't see a better way to do it, honestly. If I'm honest with you, yeah, I think we should just submit. And hope that we don't get TLE. Doesn't look good, looks terrible actually. Well, there is nothing I can do. I assume that we have to. This is actually like stupid. I don't really know why. 100,000. Oh, our penalties will be terrible. I don't even know how we will. How can we hope for a good result with such penalties, to be honest? So just like this we computed C. We will now compute this. E at least 0. E decreases. P at I gets P at I plus 1 plus yet I, we computed b, and we should take a long answer. That's actually y ends a. For a gets 0, no, a gets 1, e at most max, plus I for, why doesn't it make this sync? Did I do anything wrong? I assume that's because my indentation in the beginning is broken. J gets I, k gets 1, j is at most max, no, j should be actually increased by I and k should be increased by 1. A gets increased by k times b at j. This really should be long, and this should be long. B at j is b of minimum max minus 1, j plus I should be a correct index times c I. At least something here is definitely wrong, long. I will just mod it here, and that's it. That's it. Can we copy it here just to test? I assume we took minimum of the wrong types. I don't really want to think about it, so I will just make everything long. Still error because I did not close the bracket here. Now, come on. Okay, so we answer everything quickly. Let's just submit. Well, I can't really comment on this one. I felt terrible because like C++ solution passes, but Python doesn't. I feel it's unfair, like, to be honest. The logic is the same. Also, reusing problems from code forces is not cool. So, yeah, just like this. So. No, like, reasonable idea. You want to group by something. You see. This expression, it has three parts. It has one input, second input, and then output. So you have to group by something. And grouping by nums I seems terrible. Grouping by nums j seems better. Because why grouping by nums I seems terrible? Because like you will have 9 over 5, 9 over 2. These quantities are not connected in any way. Grouping by nums j seems a bit nicer because you will have like 2 over 9, 5 over 9, at least they are all over 9. They have common denominator, which looks plausible, but then it turns out that you can't do it. So the last reasonable thing to do is to group by the result. And to group by the result, you just need to, like, what numbers give the same result when divided by 5? Well, that's from 5 to 10, from 10 to 15, etc. And then you just use some calculus to estimate the time complexity of this loop, because as we all know, like this thing takes actually O of max over I, right? And therefore you end up with something like n over 1 plus n over 2 plus etc. plus n over n, which is actually n log n, and for n equal 10 to the 5th, it's completely fine. So yeah, why is this equal? Because if you look closely, then you are just integrating from 1 to n over x dx, right? Then you can say like, okay, n goes here, n is outside of the integral, then you take the integral of 1 over x is log n minus log 1, log of upper bound minus log of lower bound, log of 1 is 0, so you end up with n log n. So yeah, just some simple calculus. That's a very well-known trick that you can count this thing fast. So yeah, that's a shame that our solution in Python got silly, because if you look closely, it's exactly the same. Probably the only difference was that we mod it out here, but that's because we can't afford modding out at the end, because this may overflow in 64T, and in Python we don't really care, but it can't overflow like by much. Okay, the quotient is at most 10 to the 5th, there at most, no, it actually can't overflow in 64T, so it doesn't matter. I don't know what's the difference between these two submissions, apart from C++ versus Python. I feel sorry for Python users and for myself in particular. Let's check out the standings. Because our 10 minutes penalty will be terribly low, I don't even know like if we'll got into 100. Yeah, we had bugs here, so it's terrible already. Out of top 50. Yeah, and spend a lot of time here. Not cool, not cool. Yeah, and we'll drop down the order, because obviously now these people will absolve, and they will just get everything correctly, and we will fall down the order further. Typical story of LeetCode contests. Wait, what is this actually? Yeah, so Larry just solved this problem. I don't know how he solved it in Python. So he will be rated better than us, because we have two stupid bugs. Well, that bug is completely my fault. This is just I don't know if like, yeah, I understand when it's like code forces, it's competitive programming, like all languages have their benefits and downsides, but really, like, if your interview prep sites, they don't actually like judge by exact execution time, to be honest. That's like about complexities that you can get, and maybe about like not being too stupid about the constant. Okay, so not to have like 1 million times of login, right? Yeah, that's like a bad constant example. Yeah, we're dropping down the order a bit. That's just sad. I really do believe that it's not very fair. Like, whatever. I mean, even if we finished like 4 or 5 minutes before, it would not have changed much. I think we'll still end up in top 100. Yeah, actually, like, you see, like, all normal people solve it faster than us. Or actually, they solve it slower, but without bugs. It's a sad story. Oh, actually, we even have someone from Ukraine who solved everything even faster than us and without bugs. Impressive, really. Very slow start, but then got up to pace. I don't know. I don't even know, like, contest at 5 p.m. turned out to be worse than contest at 5 a.m. because of 2 bugs. That's because of 1 bug and 1 badly tuned time limit. Let's be real. Like, this is completely my fault, this is completely their fault, I believe. So yeah, that's actually cool. I'm impressed, legit. Also, guys, good job. I suppose that Larry doesn't need this kind of compliment from me, but Nagabush, let me just. I remember that you're from. I remember you from binarysearch.com, but I assume that you also don't watch my videos, unfortunately. Okay. Yeah, Larry solved first 3 problems really fast. We really should not have spent that much time here. I don't know what else to say about this contest. It was like pretty standard, I believe. First two problems really easy, then something grid-based, and then something smart. Grid-based, we actually know a lot of such problems, and the new thing for me was these obstacles that can't move. Or it's not new, it's completely the same. Wait, it's completely the same. I'm just stupid. Wait, did I really? I thought it's a different problem, but it should be the same. Oh my. Gravity. No, it's completely the same. What I was doing? Oh, stupid. Stupid. And here I did everything right. Yeah, I did not forget this, I assume. Wait, what did I do? Oh, I assume that we don't move this star. Yeah, that's why I got it wrong. Because here we don't move the stars. We just reassign the entries of the matrix. But there I went for a different approach and failed, so I really should have just copy-pasted it. This. Stupid. Damn, people, we could, like, honestly, to copy-paste, to like, copy from LeetCode, like, copy 2 questions in the contest, that's not cool. It's just banned from me. Whatever, I think it's still, no, we have fallen even further. I just hope that we will stay in top 100. And let's have the time. Oh, that actually now was the time when our, like, since once this time passes, nobody can overtake you, actually. That sounds reasonable. So now our place should not change much, but still not cool to have 2 submissions. Yeah, I really should have just copy-pasted it. I thought it's a different problem, but not. No. Could have said, like, I don't know, copy-paste is like, what, 1 minute? So really, it was possible to shave off, like what, I spent 9 minutes, people. 8, 10 almost, right? And then 5 minutes for back, so minus 14 minutes could have been saved here, and here minus 5 more, so it's like, yeah, we really should have finished in under 25 minutes, I think. Which, yeah, we should have finished around here if I was smart, but I'm not, so how unfortunate. Yeah, whatever. Next morning is a new contest. I'll meet you guys there. So for today, it's bye-bye from me. Have a great day.